たくさん。リリで何リリ、リリ、リリ、リリ、リリ。
Oh, hello,
Hello, Professor.
hello.
Hello. Can you hear our voice?
Very clear.
Can you hear our voice, Professor?
Yes.
Okay.
Hello. Yes.
We can hear your voice.
Okay.
Who is Riri? Riri, Riri.
Ray Ray. Maybe Ray Ray is Jerry's master student or undergraduate student.
Hi.
Ray is my graduate student, master student. Yeah,
Okay.
Nice to meet you.
nice to meet you.
Undergraduate student.
Yeah,
Where is AKB
yeah.
from?
Second,
AKB.
In Japan? AKB in Japan?
No. AKB just in Taiwan. Yeah, he has attended another class,
Another class.
another
Okay.
another workshop.
Oh, he should announce our conference.
Yeah, no, just to improve the teaching manpower. Teaching, yeah.
なんか勝手についちゃう。まあいい時
So we are ready. So I'm sorry for waiting our connection.
Okay. So Professor City, let me recheck the hostel you have to already book
Yeah.
during the VTCA.
Yes.
So from when to the duration of
Okay. Please wait a moment. I will check. I think it will be 2023, November 23 to November 31. We can extend. It is
okay, November 23 to
31.
November 23 to November
31, I think.
31st.
okay 31. November 23 to November 30.
So we can change, we can adjust the day of your schedule. So it is okay. This is just temporarily we requested to the university to 23 to 31. If your flight schedule is a little different, we can change.
Right. Okay. So it's from November 23 to December.
Uh,
To
so
December.
December, which December 1st is okay. It's okay.
So you told me the hotel accommodation durations is originally is from November 23 to start from November 23, right?
Yes.
Or start from November 23. So and to when is the end?
November, please wait a moment. November 23 to this is the Kiyotake dormitory of the single room.
No,
Single.
it's amazing. Yeah,
Oh.
you have the booking the dormitory for my student, all of my student. They can live together.
Yes, 12 single room. Yes, it's okay.
Yes.
Please wait a moment. We can adjust the date. We can adjust the date. Wait a moment, please.
Because
Please wait.
William asked me, maybe they can stay at the Miyazaki from during the BTCA conference and extend to next week or before
Okay.
or after BTCA.
Okay.
Maybe they can stay for 2 weeks. 2 weeks
Okay.
in Miyazaki.
Okay.
They can stay before VTCA or after VTCA. Overall 2 weeks.
Okay. I'm now checking the email. So according to my booking reservation, so we have currently reserved this 12 single room for November 20 to November 30.
Okay, November 20 to November 30.
Yes,
Oh, okay.
this is our
So,
current reservation. We can change. We can change
okay.
the date. Depends on your schedule. It is okay.
Mhm.
Yeah.
Okay.
Maybe this is about 10 days. It may be cost only one time cost, I think.
Yes.
Yeah.
Yes. Okay. 20 November 20 to November 30.
November 20 to November 30. This is my our reservation. But if your
Okay.
flight schedule depend on the flight schedule, we can slightly change. It is okay. So maybe you will change to the after conference of the December first week and so on. So we will change. It is okay.
So
This is
many rooms? How many rooms in the hostel?
that dormitory. Yesterday we confirmed we use only 12 single room for that dormitory. Another
Okay.
one you stayed last time. We received many. We are lucky. We received all the whole guest house. We received for that season, for that period. This is another guest house that you stayed last time. This
Mhm.
is we have how many? Please wait a moment. I think we have one single room. Please wait. Please count. One. How many? How many?
1, 2, 3, 4.
Three. How many three? Three twin. Three into twin. Into single room 1、2、3、4、5、6、7。7single. So triple room 1。So another one is for 6、7、3。ですから16名、16 students can stay at another dormitory.
Okay.
This is guest house. This is guest house. This
Okay.
guest house is near to the that's Kiyotake dormitory. If your students is more than 12, some students should stay in the guest house that you three stayed last time.
Okay.
So
Yeah.
that guest house room, I would like to explain. We have three twin rooms,
Mhm.
twin rooms, and 7 single room, and
Mhm.
1 single room. So that is why
Mhm.
we can stay. 16 students can stay there.
Okay. Oh, okay. I see. So, Jerry, how many students you will bring to the Miyazaki? Hello, Professor Jerry. Can you hear me?
Professor Jerry,
Or
bye
maybe
bye.
he's on Shinkansen, so the signal is not very good. He's traveling.
Where is my team?
Okay.
Here.
Jerry, can you hear me? Hello?
This one, Vincent. Yes, that. Okay.
Hello, Professor Jerry.
Okay, so there are
Mic off.
okay,
Mic off.
so Professor, I can hear you. Casey, I can hear you.
Yeah, we can hear your voice.
Okay,
Yeah.
so one chemistry has total 12 single rooms, right?
Please wait a moment. One dormitory, single room.
Yeah.
So
12 has 12 single rooms.
12 single room. Yes, 12
Yes.
single room. Yes.
Okay, and the other guest house can be 16 students.
For 16 students, we
Okay,
have
okay.
room is how many? 3, 7, 1. We have 11 room. 11 room.
Okay.
11
So-
room is triple, and 3 is 3, and 7 is single.
Okay. So if Boyan and the Wei Yuan, they will do some research or experiment in your farm, they
Yeah.
maybe stay more than 1 week in Miyazaki.
Okay.
So maybe after the BTCA or before BTCA, it's okay. So what is your suggestion? Before or after?
Yeah. In my suggestion, after BTCA is better because
Okay.
before BTCA, I will go to
Very busy.
November 10, I'm not here. I will go to Fukuoka for one presentation, and then 11 to 13, I will go to Tokyo for the expo, and then I will go to
Okay.
China.
Okay. You go to China? Okay.
Yeah.
Okay.
So that is why after BTC is better. Yeah.
Okay. So maybe they will stay at Miyazaki from November 23 to December 4.
It's okay because
Okay.
currently I am now checking the status of our booking in the another guest house that they stayed last time. This is we have already booked from 23 to 30, but we have for the December it is also free. So that is why we can get until December. So it's
Okay.
okay. Yeah. Well,
Okay.
according to the calendar, I have checked. We can receive that at the middle of November to the December is free for the
Okay.
Seonson guest house.
Okay. So,
I can fix your the schedule according to my time.
okay. So, Boyin, so please note this. So maybe you can stay with Wei Yuan from November 23 to December 4th.
November 23 to December 4.
And
Only-
yeah, so
Only December 4. Only
only
December.
December 4th. Okay.
Yeah.
I discussed with them later, maybe because I think they can do some experiments in your farm.
Yeah. Yes.
And actually, in
We can get 1 or 2 room in the farm. I also the reservation in the farm. So maybe
Okay.
1 or 2 room we will get. They will share three students, maybe a big room. So this is all.
Okay.
And
Okay.
yeah.
So maybe noodle student can join together, right?
Yeah.
Yeah, they are 3 brothers.
Yeah. Yes.
Okay.
Girlfriend.
I see.
Also, they are girlfriend.
Okay, I see. So this time I asked Boyan and Wei Yun to prepare the two papers, and I will include Professor Cici, you as one of the authors in our papers.
Thank
And
you.
I will send you the papers. Maybe you can give us some advice.
Thank you so much. Yes.
So,
Yeah.
so the topic is from the cattle recognition and the pig behavior recognition.
Yeah.
Yeah. Okay. So so Jerry, are you here? Are you online? Professor Jerry,
Professor Jerry.
you want to introduce your undergraduate student Ray, or Ray, do you want to introduce yourself?
He is now writing. I am now right at THSR, so maybe my phone will temporarily disconnect with the internet.
Yes. He's on Shinkansen.
新幹線.
Yeah.
AKB Professor is attending the Teacher AI Empowerment Workshop.
Yes. Okay, so maybe so Ray, do you want to introduce yourself first? Hello?
Yeah. From your side? Or our side? Which one?
Right.
我上次
I
报告嘛，
I
这个报告
invite invited Ray to introduce himself first.
Yeah.
Hi, my name is Chirui. I'm 英文太烂了，我没办法。
It's okay.
Okay.
So okay, so I think I asked Boyun to share his research result first. Then if Jerry if Jerry can talk can talk his network is nice, and
Yeah.
maybe we ask to Ray to introduce some research topic.
Yeah.
Okay, so boy, you go first.
Boya.
Wei Yun is on travel. He's traveling with his family right now.
Oh, I see.
Yes.
Oh,
Yeah. So only Bo Yun
Boya.
present this.
Boya.
Okay. Uh, okay. Next time I introduce three methods. All three change how the points are found. Today I will cover four more methods. This change the protocol. At the end, I will compare all seven against the baseline on the same two image, three annotators each. This is okay as the standard key points matrix. Regrounding the exponent gives D over S. D is the distance between predict to the ground truth. S is the animal size as a depth. So D over S is the error as a store of body size. Every number today is reported by D over S. Lower is better. This is the new experiment D has 3 steps. And the step 1 is on the 3D development image. Subtract from the edge annotation to get an offset vector for every key point. Step 2, remove each annotation's global translation first. Then project what remains until the anatomical axis and check whether the offset has a consistent direction. Step 3, where the direction is consistent and the error is large enough. Write the direction into the points definition. 10 definitions were rewritten, covering 17 of the 25 key points. And the next is experiment E. Keeps the definition from experiment D and spread the protocol into 5 stages. The first one is orientations, and the stage 2 is link assignment, and then post labeling, and then learn in labeling, and finally validation. Each step is a separate engine code that does one thing only, and pass its results down to the next agent. This keeps agent get the short pumps. And the next one is experiment F add radio criteria to experience E. For each candidate, I measured the projection radio on goal like this formula, like the left corner of this picture. Like this formula. A criterion is adopted only if it's consistent enough across scope. 7 are adopted covering 12 pinpoints. They are only used as a check for experiment E. And the next one is experiment G. We change only one thing for experiment E. Sorry. Instead of a crop, each key point gets a capacity of 2 views. A context view the whole image with a red circle and confirms the point is on the right part and the right leg. And detail view the top with a grid gives the Excel pixel. The pixel grid in the detail views must still sit on the right leg in the context loop. If it does not, the agent will move to the point outside the circle or set it to be 0. All the steps are to the experiment E. And here are the practical results on the 2 images. Each method improves some points, but none is the best one. And for example, the experiment F has the most low error on 5 key points than the other 3 one. But the B goes from 14 to 20. So it's a big error for these key points. And this is the experiment A to experiment G and the baseline. And the record is how many of the points the goals that are visible. The annotator also found. And the description is how far the 3 annotators are from each other. And as you can see, the protocol correct is more important than the way how to find the key points. So this is the first important to do. And these 3 are the difficult points for every method, including the baseline. So it's a property of the key points, not a protocol. They have distinctive feature. They are just points on a smooth bed. They are found in 100% of annotations. The model saves them, but they cannot place them. And the first one picture is the ground truth. It's annotated by I need. And as you can see, the county here is very it's very not the same. And also in this picture, we also label outside of the big bubble. So it's a problem, and experiment G it has the same test to annotate. So the next I will combine the pros of each experiment to develop the final annotate method and start to expand data set and calculate sigma. My project is finished. Thank you.
Thank you.
Okay, so maybe I give some conclusions or summaries. So Boeing, please go back to the experiment this time, your experiments this time. So yeah, so Boeing wants to do some. Here's the experiment A to G means that he tried to build up the agents, the agent A, the agent version A, agent team version A to version G, and to compare which agents can achieve the best annotate accuracies compare with the golden sample. So you can see in this time, the average error means that the key points annotated by the agent, the distance between the key points annotated by the agents and the golden samples. So you can see the version D to version G can achieve the better performance than the version A to version C. He present less time. So this time can improve a lot of performance. So let's go to the next slide. Yeah, the next. So here's you can see the key points annotated by the agents in these figures. The first one is the golden sample, and compare with the golden samples, the version A to the agent version A to agent version G. Here are the results annotated by these agents, and you can see that the agent G compare with, for example, compare with the agent other agents, agent G, the key points annotated by the agent G is most close to the golden samples, the key points of the golden samples. And go to next slide. This slide, this slide shows the peak who is standing up, and the first picture you see is the golden sample, and the other is the key points annotated result by the agent version A to agent version G. And you can see, for example, the agent version B, a lot of key points annotate outside the body of the peak. For example, the orange key points that he annotated by the agent version B is outside the peak bodies. But in the agent version G, you can see that the key points annotated by the agent G is more close compared with the golden sample. Yeah. So next time we will try to if the agent is training very well, we will let the agent to annotate the peak images and use these annotated images as the data set to training the AI models who can further use to recognize the key points for the pigs for the pigs. And we estimate some performers, for example, the OKS performance or AP performance to verify which agent is better. Yeah. So that's the end of his work this time. Okay.
Yeah.
So
Yes.
please keep.
Okay, Professor, so I would like to know in this slide, so there are the golden PY and the other in each experiment from A to G. What is the meaning of the marker color? There are 3 marker color, orange, blue, and green.
Yeah.
What is this meaning?
Okay. So why there are 3 marker colors in one image?
Okay. No, one color means one agent annotates. So, one picture has 3 agents to annotate the key points. So have three colors to spread.
So,
Yeah. He means that one color means one agent.
I
The annotated result of one agent. So in each pictures, we have 3 agents to label the pig image, the key points of the pig image.
Okay, so according to this figure, orange, the label of orange agent is a little far from other 2 in each experiment.
Which version? Experiment G?
For example, in experiment G and also in experiment B, the orange is a little far from other agent results.
Yeah, yes. So experiment B is not good compared with the experiment G.
Okay, yeah. So this is one, and another one is, so in your explanation for this, there are 2 types, standing and lying. For the standing, the image resolution is by them. This is the 1920 and 1080, and lying is you use the 4K resolution size. So why you use different resolution size is some meanings?
Because they are all the pictures on the website. So the size of image is
How many? Just collect from the website, the size.
I
So
see.
we use the original image
Okay.
size.
So the resource is different from different data sets.
Yeah.
Okay. I see. So currently you have the focus to keep Y based on various experiment. So it is which one is the best one to the golden label. So that is why after you receive those accurate keep Y, so currently in the big experiment, you use only 2 behavior, standing and lying. So apart from lying and standing, so we can extend and the big other actions or other behaviors by using those key points.
Yeah, yes. So actually we need to collect the data set for the pigs with behavior such as standing, lying, sitting, maybe the 3 kind of different behaviors, and use our agent to annotate the key points of these behaviors as a data set.
Okay, so Professor, so he trying to get the, how to say, the more accurate key point in his experiments. So if you use these key point, it is possible to get the weight estimation of the pig.
Wait. Oh, yeah. Yes, that's good. Very good point. Actually, we maybe go back. In other research papers, we found that some researchers use the distance of between two different key points, especially for the back of the
Yeah.
pig, to estimate their weight.
Yeah.
Yes.
Because so the key points are more accurate. We can measure the length and the width of the pig region, body region. So that is why it will be
Yes.
possible to get the weight estimation.
Yes. Yes. Good point. So if we can, yeah, so that's why we first need to develop an agent which can use to help us to annotate the key points of a lot of pig image. Then we can use the data set to training an AI models for accurately recognize the key points and use such key point informations to estimate the peak behaviors or estimate the peak weight, such as a lot of many applications we can do.
Okay. So you have any question?
クエスチョン、
OK
質問じゃなくて、なんか、感想とか。
Oh, okay. So my students would like to make some comments. Okay.
ごめん。
Comments.
In
Please.
In your research, most of the images shown were very clear and sharp with no obstructions. However, I believe that greater discrepancies in annotation would arise in situations involving occlusion or poor visibility due to darkness.
Okay, you say when the environment is darkness and the image is not very clear. So what is the accuracy of the annotate?
Yes.
Like the annotations for the key points, right?
Yeah.
Yeah, I think this is very similar to the human key points recognition approach or research. So we just try to how to make the data set, the key points data set for the pig images, and help us to reduce the human power, because if we want to annotate the key points for the pig image by people or by human, we need to a lot of time, and we don't know the correctness of the annotated key points we label on the pig image is correct or not. So if we can develop an agent who has ability to annotate the key point for the pig's images, we can save a lot of time and build up the correct data set for training purpose. But that depend on the data set. So if our data set didn't include the image with dark light or not very clear images, maybe the AI model cannot correctly recognize the key points for the pig image with the dark light or not very clear pig bodies. Yes, maybe.
Okay. Okay, Professor. Tinko, do you have any question?
Okay. For my questions, thank you very much. This I think this is very interesting research. Because it's to create the agent to an annotation. But I would like to know what is the technology base technology of the agents? Is it
Yeah. Yeah. Okay. So first one we have to clearly to describe the criteria. So please go back, William. So you can go back to the first slide. So how to teach? Yeah, here's the main thing. So how to teach the agent the good, the correct criteria of annotating the key points for the pig image is very important issues. So we need to write the correct sentence or correct instructions for the agents. And based on such instructions, the agent will learning, and they will have ability to annotate the key points for the pig images. So we need to training again and again, and to make sure that these agents has good ability to do this. Yeah, this is the technology base of this work. And if we can training a good agents, then we can use these agents to construct the data set of the pig with a lot of annotation with the key points. Then we can training these data set to generate an AI models, and these models can use to recognize the key points of the pig. And so we can use this key point to do, as I mentioned before, we can do some further research. For example, we can recognize the pig behavior, and we can estimate the pig weight. This is another research issue. If we can get the correct point of the pig images. Yeah. So many stage. So right now we stay at the very early stage.
Okay, thank you. Okay, Professor, thank you. Thank you so much. Boyan, very interesting. Please try. Very good.
Thank you.
Very good, very good.
Okay, so
Okay,
any
Professor,
other
in
questions or comments?
in this data set, he used the pig is white color. How about the black?
Black pig.
Yeah.
Yeah, good question. Yeah, we didn't try the black pig yet, so maybe next time or future work. Yeah.
Thank you, Professor. レモンコーニー、そうそう。私の充電器、部屋にあるよ。Thank you, Professor.
Yeah.
Yes.
This time we just to verify our idea is correct or not.
Yeah.
If this idea is correct, yeah, we can extend to the pigs with other color.
Thank you so much. Thank you, Professor. So
Okay.
now, so how about the Professor Jelly students or our side? So Professor Jelly student will be after his professor available.
Jerry?
Yes, I'm available. Yeah, I think
Yeah.
I will bring two students to participate in DCA. Yeah. So yeah, and today I will ask him Ray to help us to introduce our research result currently, and then Ray begin his presentation.
Okay. So, Professor, are you in the Shinkansen?
Yeah, I'm still in the Shinkansen, but right now it's temporary stop at Taichung Station, so it's okay. But I think Ray can hold the presentation very well. So
If late and the later
Yeah.
part is better, so we can start from our side at first. Which one?
Oh, okay. Maybe you can go first. Yeah.
Yeah.
Your
Okay.
side
Thank
for your side go first.
Okay. Professor. So thank you, please.
You present only
Yeah.
only detection or you want all
So it's okay.
based on time. Okay.
Yeah. So my students, he joined. This is the first time. Thank you.
Yes.
The first time. Thank you. He is the first time. So he's originally from Thailand. He is currently doing his PhD first year. He's doing the cattle research, especially in the Calvin band, so multiple camera environment. Currently, he is now doing the detection and tracking and the Calvin band. So he would like to share his current research. Please, thank you.
Okay. Okay. Thank you very much. Good afternoon. Good evening, professors. And how everyone. Okay. The camera is not moved to me. Okay, but it's okay. No. Please. Okay.
Okay. I will. Okay.
Just move normally.
No, please start.
Okay. No problem. So, okay, Sensei, it's
Please start.
okay. Okay, Sensei. Okay, okay. Today I will present my research about the study of cross-camera multi-object tracking for craving and dystocia prediction. Firstly, I would like to introduce myself. My name is Tin. I'm originally from Thailand. I'm now study for the PhD at the University of Miyazaki. I graduated from the Prince of Songkla University of Thailand. Before I'm study, I have experience as a software developer from my university. In my research, the background is everyone know the livestock tracking is significant and so valuable in current modern agriculture. With the tracking, you can ensure the food safety and ensure the cost-effective way to build to get more information and more profits. But many of research depend on the single camera, and the single camera you can limit into the limit field of view, limit coverage. And in my farm, they have the actual challenges that in sometimes the caretaker move the cow from one pen to another pen for their comfortable to track the cow. For example, the cow is near to calf, they bring the cow from one pen to the nearest pen to that they easy to manage. So The problem is what when single cameras take care only one pen, when the cloud move to another pen, the cloud will be how to say, the cloud the behavior data that should be continued must be stopped, and that is why this research is happen. This research is to make the cloud still continue even though they move out of one camera field of view to another cameras and make the continue behavior tracking. That is will be useful for carrying time prediction or dysocial prediction. So this is my objectives, and this is my all workflow, which are detection, tracking within single camera, pattern identification, inter-camera handover management, cross-camera tracking, and also prediction at the end. Our data is come from the Honkawa Range in the Oita Prefecture in Kyushu, Iceland, Japan, with 4 cameras. So this research is is the continued research from Miss Wai Nin and Rong Mong research, which is she had done the multi-object tracking in a single camera for the traveling time prediction. Okay, we move to the detection and segmentation. Detection and segmentation is to separate the object image, which is the cloud, from the background image. On detection and segmentation, we have 4 steps. First is data preprocessing, the accuracy comparisons, and the inference time comparison, and model optimization. Firstly, we create data sets with around 1,600 images. We combine from all of 4 cameras and both day and both night. So this is the pre-processing pipeline that from the video we capture the image. We automate annotation using the segment anything tool and also the previous model, and then we fine-tune the annotation by our hand, and we train the models. And this is the train setting, and this is the training pipeline from the image and annotation file. We divide into training and testing, validation, and training and validation data sets, and train the models. But we don't know this is the testing data because we design the testing data in a scenario to see that our model is work or not in the different scenario, different by the lighting, density, and occlusion. So, and also the thing is our detection model is based on the library of the YOLO you only look once libraries, but we don't know which version is based for us. Now YOLO V5, V8, YOLO 11, and YOLO 26, and YOLO 26 is very new to the research. So we need to compare them and find not only find for the accuracy, but we find the inference times, but by testing the model in 3 computer different with different GPU and CPUs. And after we got the model, we got the base model. We optimize the model by to remove the false, to remove the false negative problem. For example, the model needs to detect the cow, but the model detect human at the cow. So I do 3 things to to solve this problem. First one is to expand the class instead of the binary classification between the cattle and background to be cow, human, and background. The hard negative minings or create the background only image while using the filters to from the image that how it exists to create the how to say not a fake like the background only image. And another one is object removal using the image in paintings. And also we train with the image which is includes the non-detected object, for example the trucks or the gate, the door, something like that, into the training too. And this is the model results. For model training and at the first stage, YOLO V8 using 1 hour and 38 minutes, YOLO 11 1 hour and 48 minutes, and YOLO 26 took 3 hours, almost 4 hours. For the accuracy, this is the graph. The accuracy show that all models give the similar results or the same case study, and the performance of the model significantly when the occlusion and crowded scene appear concurrently. When the crowded scene and occlusion, the accuracy of the model decrease, and the lighting condition affect on both of the case, but become more significant in the same night and crowded occlusion. And occlusion have slightly effect more than crowded scenes. For the inference time, even though case of the complex or not complex, the inference time are the same. But when we compare between the high power GPU and a low power GPU or no GPU, we'll see that, for example, in this graph, we say that YOLO 11, we say that YOLO V8 use higher inference time compared to YOLO 11 and YOLO 26. This is some technical that we can find that maybe because of the using of the C2F block in YOLO V8 and C3K2 block, and also the implement of non-maximum suppression in YOLO 11 and YOLO 26. So in summaries, with a low training time and then YOLO 26 and slightly higher accuracy in complex scene than YOLO V8, my research proposed to use YOLO 11 as the best choice for pattern detection. For the optimization, we train after selecting the YOLO 11, we optimize then by retraining with these hyperparameters to make the model to improve the model accuracy. And this is my final model accuracy for now. So next part is the single camera tracking. On the previous research, Ms. Wise proposed the algorithm named customized tracking algorithm that's based on the intersection over union or IOUs. The accuracy is very good, but they have some problem when the occlusion happen when it's moving, and also when the pattern entering the cow. For example, they come here like they come in from the gate like this, and the model accuracy is a bit decreased. This is her proposed algorithm that is base as is my baseline algorithm too, and that is flow of the how to say flow of the tracking model. That image come to the detection model, output the bounding box and mask, and go to ID classification, update tracking, and after we got the tracking, we recorded information into the CSV file or text file or Excel files to use that information for the crabbing time prediction. And this is the experiment of the tracking model. Firstly, we define the region of interest of each crabbing plane. Secondly, we define the measurement metric. We use MOTA, multi-object tracking accuracy. Yes, and another one is identification F1 score or IDF1. And we define some GUI to monitor and to tracking the the position of the cow when the frame. We can see that when they move like when the position go very far like this, so it may be possible that not a good thing, not a real thing, because the cow cannot jump very high like this. And also we define the aspect ratio for the cow. For example, the cow is big and fat. So the cow mass region is almost full of the bounding box, and we use that to filter which is real cow or not cows. And we need to define the model bottleneck on entrance and departure scenario, because previously they fixed the number of existing cows inside, and it is not the same of the detection amount, because the detection amount is the number of bounding box, but the allowed number of cow is the another number that we use two of number to compare. If the cattle amount less than detection amount, is maybe it caused by the occlusion. So instead of fixing number, we use the exponential moving average to adjust the new numbers of the existing cow based on the current detect number and the previous number of the cow in the fields. And not only the expand, we need to create a reduction tools. And also we still propose the idea to increase the number using the cow come to the gate. For example, the cow cannot jump into the field because it's not a bird. It's a cow. It needs to come by the gate. So if the cow pass the gate or pass the bounding box, the blue line like this, it means the cow is coming, and this is the ejection. So the result is, firstly, for comparing between the IDF1 and MOTA, we found that in the video that heavy occlusion, when the occlusion occurs, both of IDF1 and MOTA still decrease, but when the crowded situation clear, the MOTA go higher, but IDF1 still less. So that means IDF1 is better for represent the real scenario, not a fake good. And another one is the when we use the automatic scaling, previously, when the new car entering, they will use the tracking ID number of existing, and they are catching each other. But now they can increase the new ID and happen for in the right side. And entrance detection result is not very well because it's still not good. It's not different from normal ID expansion. So we need to study and see that it will work or not. And this is the conclusion. This time I create the cross camera framework. The computer vision pipeline is proposed, and we create the detection model, and the Euro 11 performed fairly well. And we improve the customized tracking algorithm by enhance the dynamic numbers using the exponential moving average. But the model accuracy and ID switching problem remain the issue. Okay, thank you so much. And this supported by the Ministry of the Internal Affairs and Communication on Forward project. Yes. Okay.
Thank you, Tenko. Professor, so Tenko's report is finished. So please make some comments and questions.
Yeah. So how many cameras installed in your experimental environment?
4 camera.
Four, right?
But now it's camera by cameras. Now it's camera by cameras.
So the number of cameras is more camera can achieve more better performance or not?
I propose to be that professor, because which one camera now is tracking camera for each camera for one camera, only for one camera. But when the cloud is going out of the field of the camera views, the tracking had lost.
Mm-hmm.
Yes, and with more cameras, with the connecting camera, we can continue track, even though
Okay.
the car is moved out.
Yeah. So, Professor, so in this farm, for example, this is the state farm. So, and the Oita prefecture, maybe this is within the first the largest pig farm about in the Japan. So that farm has more than 4,000 cattle. So every day they have about 10 cattle are calving process. So that is why we choose this farm for this project, because mostly the other farms that's calving project process is occurs once or twice in a month. But in this farm, we receive many examples of that's calving counts. But the problem is in the big farm, they have, as shown in this drawing, so they have many claving pen among in this farm, only in this farm. So maybe totally more than 10 claving pens. So that is why, so when the cattle is near to the deliver time, so the staff move from one room to another room. So even though we request, please do not move the cattle, so about 3 days, because we would like to know 72 hours advanced process for each cattle to predict that this count is normal or abnormal claving, or another one is our target is we would like to predict the the starting gathering process. So that is why. So we would like to know advanced 24-hour at least, or maybe if maybe possible 72 hours continuous data. But the cattle is not in the same room because the sow move from one room to another room. So this is their process, even though they cannot follow our request. So that is why we are necessary to track the same cattle, even though they are from different rooms. That is why Tencom try for cattle tracking with different multiple camera, different cameras. So mostly within one room, most of the research within one room, they use the single camera or multiple camera. But in the Tencom case, so this is far from one room to another. We cannot control, even though we set up 4 or 5 cameras at the same time, we cannot control. That is why. So maybe they are very big farm, large scale farm. So that is why we cannot know this count is from the which place is the previous place of that cattle. So that is why. So we are necessary, even though for example in camera 1 the cattle is disappear, maybe it will be moved to, for example, in camera 3. So that is why we have to identify again, and then we will track to the continuous hour. So that is why his research is very unique. According to our survey, we are not finding the similar research. Mostly in the research is within in the one larger site, they set up the multiple camera and the same time they from different position. But in here, his research is far from one room to another room. So that is why the camera are not connected. So this is one of his research.
Yeah. So how can we identify the cow individual? If the cow is moved from camera 1 to camera 3, so how can we know this is the same cow or the other one?
Okay.
Yeah.
Yeah. So in the overall flow chart, so it is necessary to identify for the whole system. But currently, focus to the detection and tracking at first. Currently.
Yes, and another one is, on my opinion, the thing that we can make it easier to find. I think I will create some pools of the cow which is living from cameras. So we have some pool of the cow, and when the cows coming into another camera field of view, we can recheck not all the cow, but in the cow in the pool. This is the idea of Sumeno projects.
So
okay.
because according within the tracking process, he know under the one camera, he know the total number of cattle. So if the cattle number is reduced, maybe it will be moved to other room. So, but in the same time, another room, it will be increased. The number should be increased. So that is why he will focus to the decrease and increase farm within that 2 different number of cattle. So he will focus for the identifications, not all the time at the same time.
Yeah. So okay. So if the number of cattle is increased in one room, the camera can monitor which cattle should enter into this room, right?
Yes.
Or move out.
Yeah.
Oh, good. So
So because if we get the information of the cattle before the delivery, so maybe currently we have 12 hours or the maximum is 24 hours is available within the same cattle clearing pen. But if we need 72 hours, so it is not impossible to continuously because they are not staying in the same clearing pen. So that is why we would like to introduce this connection. Yeah.
Okay, thank you very much. Yeah. So, Jerry, do you
Yeah.
have any comments?
Yeah, this topic and the research works is very interesting, especially using the camera, fish eye camera to check the carbon moving and check its positions. And I have only one suggestion. Maybe you can consider the air tag become a baseline. Do you know air tag? To
Yes.
get the carbon to attach each carbon to attach a air tag become a positioner to help. This one
Okay.
if
Yes, ear tag.
Ear tag.
Ear
and
tag.
also can
What?
show his position in the barriers. So I think maybe we can make the comparison the wearable device like that. Yeah.
Identification with
Localization decisions will be every comparisons. Maybe AirTags also has another good solution candidate.
Yes, Professor. So ear tag is also one possible ways for identification, but
Yeah.
we set out the camera in the top view, so it is a little far from the cattle body. So that is why, in this sense, so we use the identifications by using only the texture values of the cattle body. So because the digit we cannot read because it is a little far. We only set up one camera in each carrying pen. So that is why it is a little far to reach the digit from that top view camera.
Okay. Yeah, just a suggestions. Maybe if the conditions is allowed, maybe AirTag also can have a
Yeah.
NAVEX performance. Yeah.
Yeah, I think so. Your advice is very good. Maybe in the cabin pen, so it is the gate. So near the gate, instead of one camera, in that sense, we can reach the ear tag number. So near the gate, we need to set up one more camera. Yes. Thank you, Professor. Yes.
Okay. That's all. Thank you. Very good.
Thank you very much.
Thank you, Professor.
Thank you, Professor.
So, Jerry, is your side to present some research results?
So I think I think Ray can share our slide for presentations, and it's our turn. So Ray, can you introduce yourself? Because I'm playing I will bring you to Miyazaki for participating in VTCA. Yeah. Introduce yourself and start your presentation.
Hello, I'm Chirui. I'm from Taichung. 我不知道讲什么了。Maybe I can start my
Presentation.
Okay, start.
presentation. Hello. Hi. Hello, everyone. My name is Chirui. Today, I'm going to share our project title, an AR-based misstatement abnormality screening system using eye tracking and AI. Today, we will focus specifically on gaze analysis. Let's start with the background. What is misstatement? It is an involuntary rhythmic oscillation of the eyes. Clinically, it serves as a crucial objective biomarker for diagnosing vestibular dysfunction and central nervous system lesion. You frequently see it accompanied acute dizziness and vertigo. In this study, we focus on the gaze test, which requires patients to hold their fixation on eccentric visual targets. This helps us evaluate their neural integrator function and detect pathological misjudgment. Next, our motivation. Currently, video nystagmography or VNG is the clinical standard. However, as you can see on the slide, VNG has several limitations. It relies on bulky and expensive equipment, requires a dedicated darkroom, and needs specialized operators. Moreover, interpreting the waveforms relies heavily on the doctor's subjective experience, which can lead to inter-observer variability. There's a real lack of automated quantitative tools. Therefore, our motivation is to develop a wearable AR smart glasses platform paired with interpretable AI for quick and objective point of care screening. Now, please look at our system architecture on the screen. We use the J7EF Gaze AR smart glasses, which are highly portable and have an integrated eyes tracker. We designed two testing modes for the horizontal gaze. The targets here sequentially at the center, right, left, and back to the center. For the vertical gaze, they appear at the center, up, down, and back to the center. Each position is holding for 5 seconds to evaluate the patient's gaze stability. This flow chart shows our clinical data and annotations receipts. We collected data for 96 clinical cases to make sure our labels are reliable. 3 ENT physicians independently interpreted the waveforms. We use a majority voting system. Cases receiving 0 to 1 abnormal vote were labeled as normal. Yielding 62 cases where 2 to 3 votes were labeled as abnormal yield in 34 cases. Please take a look at the waveform charts. They show how we expect features based on the difference between the eye's movement and the standard target trajectory. On the left, normal waveforms show the orange line closely following the blue target line. But the right, the abnormal cases shows the distinct patterns. For example, in region 1, there's a large mean error and high standard deviation. Region 2 shows a huge error and prolonged abnormal duration. And region 3 shows transition errors. We capture all these visual clues methodically. To calculate these features, we use a few formulas. First, we apply baseline correction to eliminate any subject-dependent initial bias or hardware drift. We calculate the median offset and subtract it. Then we calculate precision accuracy or AK. This formula simply quantifies the average positional deviation between the calibrate gaze and the target. Next is the precision stability or ARK. This measures the whole proportion of samples within an interval where the gaze error stays within a strict tolerance threshold of 0.1. Lastly, response latency evaluates the temporal delay between the target's transition and the gaze reaching a stable precision for 5 consecutive samples. Okay, moving to the experimental results. We ranked all 17 extract features using absolute Spearman correlation with the clinician voting scores. Please look at the table. The mean stability ratio, R mean, and mean precision error, A mean, are the top predictors for both horizontal and vertical gaze. For instance, in vertical gaze, the correlation for R mean reached minus 0.77, minus 0.574, minus 0.775. This proves our engineered features strongly align with clinical judgment. To find the best model architecture, please look at this bar chart. We evaluate 20 candidate micro MLP topology ranging for 1 to 4 hidden layers. The blue bars are for horizontal gaze, where the single layers architecture with 62 neurons achieved the best performance. The orange bars represent vertical gaze, where the two layers 32.8 configuration performed the best. because we selected this specific architecture, our models are incredibly lightweight compared to a raw coordinate model that used nearly 20,000 parameters. Our horizontal models only needs about 693 parameters. And the vertical models need about 506. That is a 28 to 39-fold reduction. This fixed computation graph is perfectly suited for device real-time screening. To verify if our feature engineering actually works, compared it against raw data. As the table shows, using raw data or baseline corrected raw data only gives us F1 scores around 0.4 to 0.5. However, our feature-based micro MLP jumps to 0.649 and 0.783. This key finding proof that baseline correction alone isn't enough. Interpretable features are the primary contributor to our success. There is a detailed model comparison for horizontal gaze. Our lightweight micro MLP achieved an accuracy of 72.9%. 72.9%, and F1 score of 0.649, while RBF SVM achieved a slightly higher F1 score of 0.692. Our micro MLP remains highly competitive and offers the huge advantage of having only about 693 compare parameters for vertical gaze. Our micro MLP for performance exceptional exceptionally well. It matched the highest overall accuracy at 84.4% and achieved a strong F1 score of 0.783, which is almost identical to the SVN. Again, it achieves this high performance with only about 506 parameters. We also conduct an error analysis, a very interesting finding. The clinician vote stratify error analysis. We found that 86.7% of the misclassification in vertical gaze are actually occur in sleep vault or borderline cases. This confirms that when the model is uncertain, it strongly aligns to cases where doctor themselves and had diagnostic ambiguity. In conclusion, please look at the 4 takeaways. First, we successfully establish an interpretable AR gas screening frameworks guided by clinician concession. Second, our 17 times domain features signification outperforms raw coordinated. Third, micro MLP provides a compact and efficient modes suitable for edge deployment. Finally, our error analysis shows that model designs are cleanly aligned with errors mostly concentrated in borderline cases. Thank you for listening.
Okay. Thank you, Ray, for the presentations. Yeah, I think this research, before I already showing some briefly previous work result to Professor TT's, and we're
Yeah.
using the AI classes. And right now, our in our further research result is that we define this program using the AI classes, and we have a 3 clinician voting results. And we're using these voting results to this vote is try to let the clinician to when they see the patient's eye tracking signals to judge if the signal is abnormal or overnormal. So that's why we have the normal or abnormal voting results, and we using this information and try to use a mathematical way to get the eye tracking signal and some quantitative analysis results to finding the relation with the voting. So that's why we have the formulations for finding the fixation accuracy and the fixation stability and the latencies for the feature engineering. So we have 70 feature items as a candidate for discover if the relation is highly relation with the voting results or not. So finally, we found out some good features suitable for AI learnings, and based on these AI learning results, we have a good is better screening model than if you're only using the raw data for AI learnings. So that's all. So I think maybe this one can is a simple way to have some disease or some recognition check detection can be and use the AI lessons in the futures. Yeah, please give us some comments with any questions. Thank you.
Professor, so thank you very much for very much interesting. So your student research. So this is you have analyzed the gaze tracking for the medical related application area. So when I listen this research, I think this it will be it may be applying to other, how to say, the neuro disorder patient, because 2 years ago we have one joint research with our medical faculty. So the disease name is, I'm now searching in Japanese name, Fabry-Bio disease. He said, I'm now searching in the English name. So this is one of the head tumor, Fabry disease, Fabry, Fabry disease. So in that patient, so his eye is very moved on both sides, and only head area have a lot of normal cases. So that is why if we apply such kind of your eye gazing, it will be very, I think, very much related.
Okay.
So this is one of the head tremor.
Yeah.
So it is very rare case. So we received the only our cooperation joint research. So the doctor only focus. This is very rare case, one patient, but with that patient, he takes the videos for every 2 weeks. So in that sense, his gazing is very different.
Okay. So maybe we can apply this program on the AR glasses for the test. Yeah. And the checking the eye moving trajectory.
Yeah.
Yeah, the signal. Yeah. Yeah, the
so,
same way like this.
Yeah, in that sense. So in that sense, so we trying his so this patient pattern are using the eye movement of his eye direction, only the image processing. But when I listen this, it is very useful for such kind of disease. Yes.
Okay, maybe next
Right.
time when I visit in VTC,
Yeah.
extra rare to show you our air gases program.
Oh,
Yeah, we can bring
yeah.
our
So do you,
result to share with you. Yeah,
okay. So you will bring this glass?
yeah, we'll bring these guys
Oh,
to let you try. Yeah. Yeah, and we also have we have already built a server in our city side, our university, and you can
yeah.
remote detection and show feedback the detection results. Yeah, I will ask the Ray to set up the server. Yeah, for the demo.
Yes. Do you understand? Right. Thank you.
So we also using this program to join the detection with MMSE for the
Yeah.
recognition, inspections. And it's a cooperator with National Sun Yat-sen University. Yeah, we also have some data and analysis if this program can early detect uh, the elder people that maybe he has some risk
Many,
falling in dementia.
yeah, yes.
Yeah, yeah, yeah.
So
Yeah,
especially
so-
in the neuro related disease is very much related. Yes.
yeah. So maybe next time I can
Mm.
show you our systems. Yeah.
Thank you, Professor.
Okay.
One more thing. Do you have any questions? So according to the results, so your proposed method is reduce a lot of parameter compared to the conventional methods.
Yeah, yeah.
And another one is according to his comparisons, so the horizontal accuracy becomes, even though the horizontal accuracy become improved, the vertical is more improved. What is the reason? So for the case of horizontal data,
Yeah,
the confidence
because
about
because
percent improved, the particle is about 30% improved.
yeah，石瑞，你到那个实验的结果，他们想要看那个垂直跟水平的数据为什么差那么多
这边吗？这个吗？
？Yes.
This
Yeah, that's a very good questions because I think because the voting and the voting results the how to say that we doing some cohort comparison and some because the voting features is based on the decision of each individual clinicians. So and also we found out that the feature correlation, especially using the experiment to compare the signal the cyclical correlations. 你可以移到那个 experiment 那一张吗？experiment
哪一个？
就是特征那一张，4个特征那一张，
这个吗？
不是 next
这个
next 对 yes this one
这个
yeah we have a ranking criteria we use experiment correlation calculation when he certified our feature functions. So found out that even the horizontal and the vertical gaze shows the same high same ranking of the features, but the vertical shows a higher correlation than the horizontal. For example, the R mean, that means the mean stability ratios. In the vertical side, the correlations is negative 0.7075, but the horizontal only have a negative 0.574. not it's less translation strong than just the vertical. I think that's why it's the evidence the shows a shows a lower performance than vertical. Yeah, but because the relation is not strong, so it's lower performance. Yeah,
Thank you, Professor. Yes,
yeah,
this is a correlation between the clinical both. Okay, thank
yeah,
you.
yeah. So we found out that in this way we can think about that if we found out that we were trying to have a classifier for some for this problem. The feature illustration should be compared with the categories results for the correlations. Then between the AI model, maybe can help the AI model have a better performance. Yeah. If the correlation is high, I think the AI model can show a better performance. That's our results. Thank you.
Thank you, Professor.
Mhm.
Professor Ellen.
So any questions? Yeah.
Professor Ellen. Ellen.
No. Actually, I'm also a member of this research project. So actually, I learned many times from Professor Jerry to talk about it.
Yes. Thank you.
Thank you, Professor.
Mhm.
We would like to discuss more after when we met in the VDCA. Yeah, very much interesting.
Okay.
Yes.
But actually,
Okay.
so were you participating in the GCCE this time, Professor Cici?
GCCE?
Yeah, this time.
Okay, really, we will participate GCCE.
Yeah, actually,
Yeah.
actually, I
Okay.
will show some another research result by using the AR smart glasses.
Yeah.
Actually, I'm a demo papers, so I will show the demo to help instructor. Yeah. So maybe we can show the AR smart glasses. So Jerry, maybe you can demo in the GCCE, not not
And also
Oh, okay.
VDCA.
Sure.
to the VPCA. So wait for some time.
Demo, Professor, VDCA. Yeah.
Yeah, we can.
Demo. Yeah.
I will ask my student to bring the AR smart glasses systems to GCCE, and maybe Jerry project can installation the systems and show you some demos.
Yeah. So I would like to
Of
include
course. Why not? Yeah.
demo. Yeah.
Okay.
And
Okay. I
our-
will bring our results, and maybe VTCA
Yeah.
the program. Yeah. Okay. Good. So I can show these results in GCC also.
So, but by the way, Professor, where is your accommodation in Kobe? Which hotel have you?
Actually, we all live in the Osaka.
Not in Kobe. Not Kobe.
Yeah. No.
Not Kobe. Not Kobe.
Not
We
Kobe.
live in Osaka.
Yeah, we
Osaka,
travel
Namba.
every day. Namba.
You will stay in Namba
Yeah.
every day.
Yeah,
from
every day
Namba.
travel to Kobe.
Yeah, we
Why?
travel
You
Kobe
like-
every day.
Because AKB will be the travel agents for us and take us to.
So
Yeah.
many just decided in Namba. Oh,
Yeah, because Osaka is more funny and
yeah, sure.
a lot of place we can visit.
Yeah, Kobe is not too much. Yeah,
Yeah.
yes.
Yeah.
Namba is
So
the
we
best.
all. Yeah, so we all live in Namba.
I see. We need to consider. But we are not yet resolved. Yeah.
Okay.
Mm.
Okay. And oh, let us to make sure our schedules in VTCA this time. So I and Jerry, we will arrive to Miyazaki on Monday.
Monday, yeah.
Yes,
Yeah.
and we take the Tiger Air. So we arrive to Miyazaki very early, around 9 o'clock in the morning.
Okay.
And we leave Miyazaki to Fukuoka around the Friday afternoon.
Friday,
Friday afternoon. Yeah.
28, 27.
Around maybe around 16.
37 afternoon.
Okay.
We will move to
Move to Fukuoka. Yeah, and back to Taiwan in Saturday.
Oh, too short.
28.
Too short.
Yes, this is our schedule.
Okay, so you will arrive on 23. So we will go to 24 to our another to Nobeoka City. So because Professor AKB want to go to the Nobeoka field for the aquatic science. And another one is I'm now arranging to other university. This is the Kyushu Medical Institute. It's in Nia and Nobeoka. So I will arrange for 24 tour.
24.
24 tour, we can join.
Study tour,
Yeah.
study tour of
Because
our
of,
group.
of,
Not the conference tour. This is another tour.
Yeah, I know. I see. So
Okay.
24, right? In November
Yes.
24, there's
Yeah.
another general tour to visit the
Our university.
hospital.
Yeah. So fee to Nobeoka City and another university for medical
Yeah.
research. Yes.
Okay. Yes.
okay. Thank you for your arrangement.
So
Yeah.
Professor Kelly, how many papers were you submitted? And please invite many your colleagues.
Yeah, I will tell my student. Basically, I will bring 2 student participant in VTCA, including the Ray. The student today present the paper. Yeah, at least two. Yeah,
least-
please. Yeah. So maybe these 2 students will stay with Professor Allen's students.
Yeah.
Join his group for the conference shipping. But I think the time will not the same because it's too long. I think they may stay in Miyazaki for 5 days. I will
I
ask
see.
him to book in the tickets right now.
Okay, so I would like to collect your students and your group detail schedule, and I will arrange the whole accommodation of our 4 students.
Okay. If we already arrange any schedule, I will ask Ray to provide you the information.
Okay.
Especially for because you have to arrange some dormitory, right? And a
Yes.
hostel. Yeah. Okay.
Yes.
Okay. I will ask Ray to handle this quickly.
Yeah. Professor Ellen, so please invite more your colleagues because we have only a few papers currently, not too much.
Actually,
Yeah.
Professor Hong Mengfeng, Professor Hong, the Professor Xie, will participate in VTC this time. And in my special session, I have already asked my student to submit around 10 papers.
Yeah. Please correct more paper. More paper.
Okay. So
These are
Tuesday
very
is
ideas. So when I met in Taiwan, Professor AKB suggest me to extend at the beginning of the September because currently, so in Taiwan, the university are the summer vacation, so that is why no students. So he suggests me to extend at the beginning of the September.
Yes. So he need to so he's responsible for inviting more and more people to
Yeah.
participate in this conference.
Please.
It's
Yeah,
responsible.
I think the date submission date moved to the beginning of the September or October.
No.
September.
No.
September, right?
Yeah.
Because currently we also prepare our
August.
ICCE.
August 20.
Yeah,
The due date
August.
is, oh yeah, it's coming soon. August 20.
August
Current
20.
deadline is August 20, so we need to extend.
Yeah, I think.
August 20.
I think.
Yeah, okay.
August
I will
20,
prepare the paper. All right.
This
I
is
will.
the second extension, right?
Yes.
Yeah,
For
the third
Okay.
extension.
final extension, please advise me.
Mm-hmm.
Okay.
When should be the final extension?
Extension.
Now we are preparing the ICCE paper, and this one, okay, I will quickly have a meeting with my students and prepare maybe two or three papers for the conference, maybe more. Yeah.
Okay, thank you. We will extend because when I discussed with Professor Ba, he said, so our proceeding will be appear after conference. That is why it can be extend, he said. But if we extend more lately, so other country are necessary to apply the visa. So that is why it may be better at the beginning or at the middle of September is better, I think. Maybe for
Okay.
Thailand, it's not necessary to apply the visa, but some countries should be applying the visa.
Okay. I know.
But we
So-
would like to collect more papers. So that is why, in my opinion, I would like to extend some more days.
Okay.
So please advise me, professors, your ideas.
I think maybe 2 more weeks.
2 more weeks.
Yeah.
Okay. So maybe at the beginning of September.
At the beginning of September.
Yeah.
Okay. So, please invite more friends.
Okay.
Your group, yeah. So we would like to push AKB.
Yeah, you have to push AKB.
Yeah, AKB is always busy.
Actually, the flight of the tiger fly is more expensive this time because I think a lot of participants will attend the conference on Monday. Will take this flight. So
Oh.
right now it's very expensive. The flight ticket.
From Monday.
Yeah, from Monday direct to Miyazaki, the tiger flight is very expensive.
Oh, so how about the direct flight from Kaohsiung to Fukuoka?
It's also expensive.
Also expensive.
So expensive.
Oh, how
Yeah.
about the transit from Korea?
You have to, you have to stay Korea overnight. Yeah, overnight. If you stay Korea overnight, over one night will be cheap,
Yeah.
very cheap.
Yes. So maybe the students should use this because they can visit to Myeongdong in the Korea.
Yeah.
Yeah.
The one round direct to the flight ticket from Taoyuan International Airport to Miyazaki is around 10,000 NT dollars.
10,000 NT dollar means
Only one round, not
Oh.
bad. Only from Taoyuan to Miyazaki, 10,000.
Simple trip 现在有那么贵？
很贵啊，一万块，1万块。
11月
Yeah.
23号那一天。
Yeah, only simple trip. Yeah, it's 10,000.
From Taoyuan to
from Taoyuan
Miyazaki.
to Miyazaki.
5,000.
Oh.
50,000.
50,000 yen.
Yes.
Only single trip. Single trip.
Oh. So please transit from Taiwan to Korea.
So I think a lot of our friends or a lot of faculty will participate in the VTC. So the flight ticket is more and more expensive every day.
Yeah.
So maybe Fukuoka transit will be cheaper.
Fukuoka is not really.
Oh, another
really.
one is from Kansai Airport. Kansai Airport.
But if you take the airplane from the November 20
Yeah.
from Taoyuan to Miyazaki is cheap.
Oh, so please choose November 20.
November is cheap, but November 23 is very expensive.
Oh, so
Yeah.
please choose November 20.
Mhm.
Maybe
So
November there are a lot of golf tournament. Golf tournament.
Oh,
Yeah.
golf
Good season.
tournament.
Yeah.
Mhm.
Continuously golf tournament in continuous 2-3 weeks. Yeah.
so right now the accommodation is very full in Miyazaki.
Oh, I have a lot of accommodation reserved for our friends and
Yes.
Aoshima. It is a little cheap, maybe 6,000 yen. Aoshima. So they will take the the bus pickup from the dormitory to the conference site. It is okay. So I give the information of that Aoshima hostel. If your friends need to reserve the hotel, we have temporarily reserve a lot of hotels for our friends, especially for Taiwanese. Yeah. So if I think the hotel and the currently is maybe expensive, but we have a lot of in our hand we have a lot of hotels. We have all yes. For your group, maybe I think maybe Taiwanese will join this conference. That is why we reserve many hotels.
Okay.
OK，所以青岛那边的饭店 OK，
Distribute this
so
information
they
to
have
you.
a shuttle bus to the conference hall, right?
Yeah, yes.
OK，
I
Okay.
was
We have all already booked the hotels. Yeah.
no, if not yet, some professor are not yet.
Maybe we will ask them.
Yeah, Oshima's hotel. OK，
Okay. So
Keep in touch because it becomes closer.
next time the meeting time next.
Which day is better?
I think how about September 22, 22nd?
22nd. Yeah, it's okay.
September 22nd?
22nd, okay. Even though we are the holiday in Japan, but okay.
Really?
Our
Really?
the calendar is holiday. Are you in 22? Well, okay. Our lab is not holiday.
Your lab have no holiday.
Holiday. So
Okay.
currently now I'm not asking in front of me. So my student is okay in 22. Yeah, he is okay.
I'm not
Okay.
Japan. I'm not in Japan.
Wow, you are done to Thailand, eh?
Yeah.
But 22 is okay, Professor.
It's okay. So what time is you are available?
Anytime okay, because we are holiday.
Anytime. So how about you, Jerry? Professor Jerry?
OK, yeah.
The same
Maybe
time? 15,
maybe
30?
we can
15
early.
is okay.
Allow
Earlier.
me to check my maybe you can earlier. Maybe you can start from 2 o'clock Taiwan time.
How far is okay?
Afternoon 2 o'clock. Yeah.
3 o'clock. 3 p.m.
3 p.m. or Japan time.
Yeah, people in Japan.
Yeah.
For September 15 or September 22, which one?
September 22? 22, right?
好不好？差不多 September 22
Okay.
and start from in Taiwan.
Taiwan time, 2 o'clock.
2 o'clock p.m. and Japan
Right.
3 o'clock p.m.
Okay. Okay. We are okay. 15 because that day is holiday.
Thank you.
Yeah. Thank you so much.
So see you next time.
Yeah.
Okay.
September 22.
September
Our
22.
time is 3 p.m. Your time is 2 p.m.
Yes.
Okay.
Okay.
Okay, Professor.
Okay. So Professor CC, I will send you the mail with 2 papers submit to VTCA. Only abstract papers.
Yeah.
But my student will give the full presentations in the conference.
Okay.
Papers
Okay.
only abstract.
Okay. So
Yeah, I
you
will too.
will upload the full paper or after that?
Actually, we upload the abstract papers, but we will give the full presentations in VTCA. Full
How
ideas.
proceeding? No need.
Actually, I want to I plan to submit the full papers to IEEE conference. So how about this? Yeah, maybe in the next year, in IEEE conference, for example, ICCT Pacific 2027,
Okay.
or some conference in Japan.
Okay.
Yeah, and this time just only abstract paper.
Okay. Okay, Professor.
And
So
the registration fee is quite cheap.
quite cheap. Yeah.
Yeah,
Cheap.
very cheap.
So please bring all of your students, the whole lab.
More than 10.
Yeah, because we have,
More than 10.
I have reserved a lot of our dormitory room.
Yeah.
So you can bring your whole laboratory and the laboratory seminar trip to Miyazaki.
Yeah, whole laboratory. Yes, almost
Yeah.
whole laboratory. Yeah,
Yeah,
almost.
almost.
And we can, the travel team.
Yeah, your laboratory goes to Miyazaki.
Travel.
Yeah.
Okay.
Yeah.
Okay, so okay, this is the end of our meeting right now.
Yeah.
The end.
Okay.
Okay. So
Okay.
See you. See you next time. Yeah.
Okay.
Thank you.
Thank you very much.
Okay.
Thank you so
Thank you
much.
very
Bye-bye.
much. See you.
Bye-bye.
Bye bye. Bye bye.
Bye-bye.
Bye
Thank you.
bye.